with 3 different heating rates, it's very possible I can get three slightly different curves, or they look different, simply because of that thermal gradient issue. Okay, not necessarily because the transition itself is shifted per se, but the sample itself takes a longer time to get to that temperature because you're heating it so quickly. Okay, so by the time the furnace, for example, is at 200 degrees, your sample's only at 150.
Yeah.
So it's now going through the transition, but you look at your raw data, it's going to say it's going to happen at 200 degrees. So it's a sort of a confusing thing to look at when you start changing your heating rate. Now, of course, sometimes you may want to do that for certain reasons. For example, I may want to cool my sample really, really quickly because I don't want it to crystallize. Okay, so that means I'm basically, quenching my sample completely. That's possible, okay, with certain samples. So in that way, changing my cooling rate can change what I see in my subsequent heating, because now I've quenched it completely and there's no crystals in there. So it's going to look completely different than if I quenched it at 5C per minute and I actually allowed it to crystallize itself. Okay, so it'll be 2 completely different experiments, or 2 different sets of data that you'll obtain by just changing that cooling rate. Okay, but that's a really good question, because you don't want to sort of randomly choose these numbers. You want to make sure that you have some control and some understanding of where the numbers are coming from and why you're using those numbers before you get in and just kind of type in whatever. That's not really a good plan. So make sure that you sort of know and understand what you're trying to see from your material, how stable your material is, things like that, so that when you come here to do the DSC, you have an idea of kind of what you are expecting to see. Okay, that's a really good point. So going back to this, this heat cool heat, from what I was mentioning, this is going to sort of help you look at your sort of thermal history on your first heat, and then sort of imparting your thermal information into your material by your cooling, and then sort of analyzing what happens in the cooling by looking at the second heating scan. Okay. The other way that you can do that is by using the cyclic command. So in the cyclic command, there's a few less numbers, but there's one definitely very different number in here. So you have a lower temperature, you have an upper temperature, and a heating rate. Okay, so let's say I'm going from 0 to 300 at 10 degrees C per minute. Okay. Now, the last number here says number of cycles, and of course, it does say a cyclic program. So, let's say I want to run this 5 times, just as an example. When you go to the Segments tab, you'll see I have a few different commands that get stored in here. The first one, again, I start at 0. You have a data on command. So the data on, data off commands, like the one down here, those actually control, or they can control what you do and don't record. So if there's something within your experiment that really has no value to you in terms of analysis, you can surround it with the data on, data off pair of commands that basically says don't record that section. Okay, so it just helps you sort of save some data space, as well as make things less confusing when you analyze them later. Following the data on command, we have an isothermal. So you're going to hold at 0 for 5 minutes. Your mark end of cycle, I described what that was before. And then you're going to ramp at 10 C per minute to 300 Celsius. Mark end of cycle, another isothermal at 300. And then you're going to switch the data recording off. Okay. Then you're going to go to repeat segment. So this says repeat segment 1 for 4 times. So what it's going to do is that it's going to look for segment 1, which is right back up to the top here, and it's going to go right back down that list until it hits this command again. So for those that have done some computer programming, this is basically a looping statement, right? So it's going to keep repeating this until you tell it to stop. And what tells it to stop is the second number. It says 4 times. So the first time it goes through, that's 1. And then it hits this statement, goes back up, that's 2. And it does that 4 more times for a total of 5 cycles, right? Which was the number that you put in down here, okay? So that's what makes this thing a cyclic program. Now, what you would realize, the difference between the cyclic and the heat-cool-heat is that there is no cooling statement here, okay? I didn't say cool down at X degrees per minute. It went from 300 to 0 as quickly as it wanted. So it's a quenching mechanism as opposed to a controlled cooling. Now, the difference between the cyclic and the heat-cool-heat in this type of way is that if you have a material that's not crystalline at all, then controlling the cooling may not be very beneficial to you. It may just be more time added to the experiment. So in this case, the cyclic program will actually be helpful because you don't really care how fast you cool it down as long as you cool it below your glass transition temperature, okay? Or if you want to keep your sample from crystallizing while it's cooling, then the cyclic will also help again because, again, this is a quenching cooling cycle so that at least you will have the least amount of crystallization happening and the instrument will cool as fast as it can. So it's not a controlled 10, 20 C per minute type of thing. It's just going to go as quickly as it can down to that temperature. So your heating rate essentially is going to vary as it goes across that temperature range. And that's also why it doesn't record that cooling step because there really isn't a lot to see in there in terms of doing a proper analysis. Typically when you do a proper analysis, you want to control your heating or cooling rate so that you can actually know what's happening physically and the math works out and all these other things are easier. When you're not controlling that, everything becomes very complicated. So typically, as is done here, basically as you go into your quenching step, which is the equilibrate function, you're basically switching your recording off. So the only thing that you should see here is 5 heating cycles, and that's it. Okay? So that's basically the difference between the heat-cool-heat and the cyclic is that you can do multiple heating scans, but the cooling is always quenched, right? So it's non-controlled. With the heat-cool-heat, you're doing 2 heating scans and then a controlled cooling in between them so that you sort of know what you're going to be doing to your sample, whether you're crystallizing it or what have you, okay? A lot of times people want to sort of mix and match or they want to do multiple different things such that the templates themselves don't sort of do everything they want them to do. In this case, you can simply go to the custom tab, okay? Now the cool thing about the custom tab is that you don't have to start from a blank slate, okay? If you started from one of these templates, whether it be the heat-cool-heat or the cyclic, and then you switch to custom, it actually keeps everything that was there. So I could actually start from something that I know, right? And then I could go ahead and edit that based on what I want to see or what I don't want to see or what I want to add to the end of the experiment, okay? So when I click the edit button here, you will see that now I have access to all the sort of commands that are, that you have the ability to use during your experiment. This does come with a pretty substantial help menu, and you can read into exactly each one of these things and what they mean and how to use them. I'm not going to go through every single one. There's quite a few. But you will see some that sort of make a lot of sense to you. For example, you will see the equilibrate function that we've used before, the ramp, the isothermal. There's an increment if you just want to jump to a temperature really quickly. There's a step function. There's a lot of other cool things that you can use in here. Here's the repeat statement down here, your data, recording function, and your mark in the cycle. So they're all on this list. There are other things on this list that you can use, but you can access the help menu pretty easily for them to describe what they actually do. In order to add it to this list, you basically click and drag. So I can click and drag and place it anywhere I want. okay, and just let go. Once you do that, you have these, if there are things that you can change in here, there are these boxes that you can type in whatever changes you want to make. For example, if I only wanted to repeat them, twice instead of 4 times, I can just change that number to 2, etc., etc. Once you're happy with what is in here, you simply hit apply, and it will save whatever is in there. Okay, so all you need to remember in that case is to make sure that you put all of the commands in the right order. It just goes through these commands, so it goes from 1 all the way down. So make sure that you have everything in the correct order and in the right place with the right temperatures, etc., because it won't know what you meant to type. It only follows whatever's in there. So once you prepare your experiment, you can save your experiment by hitting up here. You save your procedure. You can save your procedure to your folder and sort of call it back if you want to use it for another set of samples some other time. Also, you can, this procedure is saved in the same data file that you're going to collect later on. So you can always pull up that old data file and basically copy the procedure back here. So those are the 2 options that you have. If you don't want to remember what your procedure is, you can always save it, or you can just pull up an old file that you know you had that on and bring it right back into the running queue. Okay? So there's no need to worry about forgetting what you did. It's all saved. Okay? So once you're happy with this procedure, essentially you're ready to run. Don't worry too much about the advanced tabs down here. They're just telling you to go to the standby temperature. And once the experiment's finished, it will actually remove your sample and remove the reference. So again, you don't have to physically do anything. You just have to set these things up, make sure that they're correct, and you're ready to go. Okay? Now, remember, we set all of this up in the design view. So basically, the instrument does not know that it needs to do any work. So the start button, which is up here, is grayed out. So I can't actually press start because it doesn't think there's anything to do. So to transfer what I just prepared into my running queue, I basically just click and drag, and you would see that it copies it directly into the running queue. And now everything that I just had down here is now up here in exactly the same way. And you would see, if you look on if the touching is actually working, you would see a number light up, which corresponds to the number on the auto sampler. So now it knows, now that it's in the running queue, it knows that it has number 35 to run. So when you hit start, it will start from the very first experiment and go down the list and run number 35, 36, whatever. Okay? So also, and again, you can create as many of these as you want. Also, what you can do is that if you click on this and you click one of these, you would see that it automatically increments the pan number. So if you have a list of different pans and you put them in the increasing order on the auto sampler, if you keep copying down, it will basically increase the order of the pan automatically. So that's a convenient feature, and it basically copies whatever you did up here to all the other experiments. So if these are all the same experiment with just different samples, then you don't have to prepare 4 completely new experiments. You just have to prepare your 4 samples and copy the experiments through, right? And of course, put in the correct size and pan mass at the top. So basically, everything else is saved for you. Also, it does not overwrite files by default. So if you forget to change your file name, for example, it will simply increment the file name. So this will have a test 1 at the end of it, so that you know, oops, I forgot to change my file name, but it's a completely different file anyway, so don't worry about it. And you can always change your file name later, okay? So, the program itself is pretty intuitive in that sense. It sort of keeps things in order. It doesn't overwrite files. So you're pretty safe with things like that, just in case you make any mistakes or things like that. So that's pretty much it. And as you can see, there is a sample in the running queue. Now the start button is green. Now if I hit start, it will go into sample 35. It'll pick it up. It'll place it in there. It'll take up your reference pan, and it'll keep going. Okay. If I do it now, nothing's well, it'll try to pick up a pan, but there's actually not one in there. So it'll give you an error. So just remember to have the right numbers written down, just in case you mix things up like that. Okay, so basically, you would hit start. Your sample will start running. It will automatically switch to this results tab down here, and you would start to see a live feed of your data come out as soon as it starts recording something. Okay. This results tab is also where you would analyze your data. So if you were to have a copy of this on your laptop,